You Dahia.
Assalamualaikum, ma'am.
Can you see the whiteboard clearly? Dahia?
Yes, ma'am, I can see it.
Okay. How are you?
আলহামদুলিল্লাহ, ম্যাম। আপনি ভালো আছেন?
Good morning, everyone. Please write down your student ID in the chat box. Please keep one lecture khata and pen with you. Please give your attendance. Only 14 participants. Okay. Still you are joining. Only 15 participants. Okay, let's start our class. So on the last class, I discussed about the units of expressing concentration. So I would like to ask you some question before going to the next topic. Anyone who can please try to give the answer. What is the basic difference between molality and molarity? If you willingly give answer, it's okay. But if you don't, I will ask you randomly, anyone. So please, Ashik, can you hear me?
Assalamu alaikum, Miss.
Walaikum assalam. How are you?
Miss, fine. And how are you, Miss?
Alhamdulillah. Okay. So I have discussed about molality and molarity, right? On the previous class.
Yes, Miss.
So do you know the basic difference between them?
Miss, molarity is most probably is counted in 1 liter.
Mola.
Riti. Yes, Miss.
Riti. Okay. 1 liter.
And Miss molality, Miss, I have forgotten about the molality.
So,
Ma'am,
it's very basic question
ma'am,
and common. Yes. You want to say anything? Okay.
ma'am, molarity counts in liter, but molality counts in the mass.
I think not clear. I have given you a slide that is a solution. You should
Yes,
see
yes,
the
ma'am.
difference in the last page on the slide, that the basic difference between molality and molarity. Actually, what is the basic difference? One point is very important. Anyone try? Christy, can you? Christy, can you hear me? Can you give me the answer? What is the basic difference? Christy?
Ma'am, Assalamu alaikum.
Walaikum assalam.
Ma'am, can I say?
Yes, of course.
Ma'am, molarity depends on temperature, but molality doesn't depends on temperature.
Yes, you're right. But what is the reason? Can you explain? Can you
Yes,
explain?
ma'am.
Okay, okay. Tell me.
Yes, ma'am. Ma'am, molarity liter, uh, and the
Okay. Tasfir. Tafsir.
yes, ma'am.
Okay. What do you are trying to say? That molality is temperature independent, but molarity is temperature dependent.
Yes, ma'am.
That's why the reason of their difference. But actually, you should mention that in case of molality, we calculate. We doesn't need the total volume fixed. It is not volume dependent, but molarity is volume dependent. That's why it depends on temperature.
Oh,
So why it is volume dependent? Because if you want to make some molar solution, I'm just giving a review of the previous class because it's important to how to know how to measure molar solution, molal solution, normal solution. So you should know these things very well. Okay. For any kind of experiment, research, or your subject is nuclear science and engineering. So it's very important to know the measurement, how to measure the solution, how to take the chemicals. Okay. How to calculate the nature of the chemicals, everything. So in case of molarity, make you have to make the total volume up to 1 liter. You can see here, once the solute is dissolved, add additional solvent up to 1 liter. That means you can see here, molarity is the matter of total solution will be 1 liter. But in case of molality, you can see here that your solvent is counting, not total volume, not total solution. You know, solution is a mixture of homogeneous mixture of solute and solvent. Here, separately, you have to take 1 kg of solvent. So the total volume will be more than 1 kg. But so the volume is not fixed for molality. But in case of molarity, it is fixed because you have to calculate the total volume. That means here solution 1 liter. This is the basic difference. Okay, I think it is clear to you now. So did I explain the mole fraction on the last class? Do you remember this thing? Did I explain this topic, mole fraction, on the last class?
No, ma'am.
Okay. So you can see here mole fraction. Mole fraction is the ratio of number of moles of a substance over the total number of moles of substance in solution. So you can see here in the whiteboard. Can you see the whiteboard?
Yes, ma'am.
So suppose you have two substance A and B in a beaker. So what is the mole number of A, Na and N, B? Is the mole number of species A and species B. So what is the mole fraction? You have to calculate the mole fraction. So if you want to calculate mole fraction of A, they are trying to say that mole fraction is mole fraction of A is the number of mole of A divided by total number of mole of the solution. Is it clear? So if I add another species here, what will be the mole fraction of A? Can anyone tell me this? Anyone?
fraction of C খালি add করে দিবেন
So I should have add whole number of C here, right? So if you want to calculate the mole fraction of B, what will be the change? Here, just mole number of B will change. If you want to calculate the mole fraction of C, you have to change mole fraction of C. Here, number of mole of C. But the total mole fraction is fixed always. Is it clear? Is it clear? Please
Yes,
respond. Okay. So now I will discuss about another important unit, that is normality. This is normality. We have discussed about molarity, mole fraction. So normality is denoted by n. N equal to equivalent weight of solute divided by 1 liter of solution. You can remember the molarity. With molarity, here it is the similarity here. In case of molarity, we have number of moles of solute divided by 1 liter of solution. But for normality, here only the difference is here equivalent weight of solute here. But these things is same. That means in this case you have to take the solvent up to 1 liter, because here it is solution. The total volume should be 1 liter. So you have to add solvent after you taking the solute. At first you will take solute and then you will fill with solvent up to 1 liter. The solvent necessary need to be 1 liter, like molality. But with molarity, here normality is similar. It is also temperature dependent, volume dependent. Because whatever the solute can be anything, but the total solution will be always 1 liter for any kind of solute. But the change will be in the equivalent weight of solute. So do you have any idea about equivalent weight? How to calculate the equivalent weight of a solute? বাংলায় যেটাকে বলে তুল্য ভর। You have studied this. So what is the equivalent weight of a solute? Suppose in molarity for sodium hydroxide, if you want to make 1 molar sodium hydroxide, you have to take 40 grams of sodium hydroxide in 1 liter solution, right? So what is the equivalent weight of sodium hydroxide? For 1 mole, it is for 1 mole. But it is for 1 mole 40 gram. But what is the equivalent weight of 1 mole of sodium hydroxide? So you have to convert this thing. So now I will give you some method to how to determine the equivalent weight. So equivalent weight calculation for acid. So if you have the acid solution to prepare, then you have to calculate the equivalent weight of that acid. So suppose you have HCl. Suppose you have H2SO4. What is the mole? 1 mole weight? 1 mole is 37.5 something, right? Gram. Right? For sulfuric acid, 1 mole, it is 98 gram. This is
36.5 হবেন।
okay. Yes. 36. So this is the normal weight. But what will be the equivalent weight? How to calculate? So for acid, it is calculated by depending on this S plus ion, the replaceable hydrogen ion on the acid. So if you dissociate this acid, it will be dissociated by this. You can see that here only one S plus ion, right? So it will be for equivalent weight, it will be divided by the equivalent number. What is the equivalent number? Equivalent number is the number of S plus ion present in the acid. So it is 1. So actually for HCl, the weight, equivalent weight and molecular weight is similar because the number of S plus ion is 1. But in case of sulfuric acid, you can see here 2 S plus ion, right? So what will be the equivalent weight? It will be divided by the equivalent number. This is the equivalent number, 49 grams. Right? Is that clear? For acid, what is the method to determine the equivalent weight? You have to consider the replaceable hydrogen ion present in the acid component. So you will divide by the equivalent number. This is the equivalent number, and we'll get the equivalent weight for the acid. Is there any confusion for in this topic? I think it's here. So for another species, base, if you have base, suppose if you have sodium hydroxide, if you have calcium hydroxide, In case of base, you have to calculate the OH ion present in the base. This is here only the equivalent number is 1. Here the equivalent number is 2 because 2 hydroxyl ion, here 1 hydroxyl ion, here 2 hydroxyl ion. So it's very easy. You will take the molecule or the species that you want to make the solution. Then you will just see what is the nature. Is it acid or base? If it is base, then you have to calculate the number of hydroxyl ion. If it is acid, you have to take the number of H plus ion. So molecular weight will be divided by the equivalent number. So this is the equivalent weight equation. Can you see this equation? This is equivalent weight equal to molecular weight divided by equivalent number, and this equivalent number is for acid for base is the number of hydroxyl ion. Okay. So for sodium hydroxide it is 40 equivalent to molecular weight, but the equivalent number is 1. So the equivalent weight is S11. Is it clear? Is it clear?
Ma'am.
So I will ask Huzaifa Sami. Huzaifa Sami, can you hear me?
Yes, please.
So can you please tell me what is the normality? What is normality? Can you explain?
Miss, normality is the mass of uh, solute inside 1
Anyone?
liter.
Okay, your answer is wrong. I think you should concentrate, please. This is very important topic for you. Please concentrate. Okay, no problem. You just go through the slide after the class anytime. Okay. I think you will be clear about the topic. It's really very important for you. The
Thank you.
units of expressing concentration is very important for you if you want to become a great scientist in your subject, or if you want to like do something to make your research thesis, anything. You have to know this thing because it's very key point, key in topic for your subject. Okay.
Miss, may I?
Okay. Anyone? Sure.
Miss, normality is a measure of concentration equal to the gram equivalent weight per liter of solution.
Yes.
I'm not
Very good.
sure, miss.
Yes. You are right. So, do you
Thank
know the gram equivalent weight? I have already discussed for acid and base. So, okay. Thank you. I will ask you later. Person name?
Miss Alif.
Alif. Ashik Alif. Okay. Thank you. Thank you very much.
Smart kind of.
Okay. Now I will calculate for another base pair. Number 3 point is I have discussed for acid base. Now I will discuss about for ionic reaction. For ionic reaction. So our solute can be anything: acid, base, salt, or oxidizing agent, reducing agent. So you have to know all the things, all the way to calculate the equivalent weight of each of the solute. So this is for ionic reaction. So ionic reaction, you can see if you have sodium chloride, this is the salt, this is the ionic. If you add some water, it will be dissociated into this one. If you have aluminum sulfate salt, then it will be dissociated. Here it is aqueous. Here it is aqueous. Okay. should have this 3 plus this is sulfate 2 minus. So here for this one, the equivalent number is the number of ion. It can be anion, it can be cation. Okay, it can be anion, it can be cation. So here you can calculate only one thing, anion or cation. So number of anion is 1. It is the equivalent number for this one. What is the equivalent number of this one? Here 3, but here only 3 for 1 aluminium. But for 2 aluminium, it will be 2 into 3 equal to 6. If you calculate this one also, it will be 6 also. Anyone, anion or cation, you can calculate anyone. Because if you want to make some salt, you should have the anion and cation similar. +1 -1, +2 -2, +3 -3. So you can take any part, anion or cation. Okay. So in this case, for sodium chloride, you will have the molecular weight equal to the equivalent weight, because the equivalent number is 1. You have to divide the molecular weight by 1. Maybe sodium chloride have what is the molecular weight? 58. Maybe 58 point something, 5 something. So if you divide it by 1, it will be similar. Okay, 58. But in this case, if you calculate this one, what is the molecular weight? I don't know. Maybe molecular weight you just have x divided by 6, then you will have another weight, because it is not 1. So molecular weight or equivalent weight will be different for this case. Is it clear for ionic reaction how to calculate the equivalent weight? Please say something.
Yes, miss.
Okay, thank you. So now the last one is for 4. Number 4, the redox reaction. So first of all, I know you know what is the redox reaction. Redox means reduction plus oxidation. Redox from reduction rate for oxidation is ox. So by combining this, it is redox rate plus oxidation. So reduction means plus electron. Electron will be accept, and oxidation means minus of electron. Electron will be released. Okay. So here you have to, if you want to calculate the equivalent weight, you have to calculate the molecular weight divided by oxidation number or this is for which element show oxidation, but another, this is for reducing agent. Oxidation reaction. But for reduction, it will be equivalent weight equal to molecular weight divided by reduction number. What is the reduction number? Actually, oxidation number, you know what is, actually it is জারণ সংখ্যা, বাংলা যেটা বলে জারণ সংখ্যা, বিজারণ সংখ্যা। মলিকুলার যে ওয়েটটা থাকবে, আমি সেই স্পেসিসের জারণ সংখ্যা যেটা, সেটা দিয়ে ভাগ দিব। জারণ সংখ্যাটাই হবে তার ইকুইভ্যালেন্ট নাম্বার। And reduction number means বিজারণ সংখ্যা। So I'll show you two examples here. Okay, you can see. You can see. Can you see the slide, please?
Yes, ma'am.
Student, can you see?
Yes,
So
ma'am.
can you see the the things here? You can see the example for chromate. During the reduction of potassium dichromate, it converted to chromium 3 plus by accepting 6 electron. So what is the reduction number for this reaction? 6. So equivalent weight will be that the number the molecular weight. This is the total molecular weight for potassium dichromate. Okay, 294 will be divided by 6. So after dividing, the equivalent weight will be only 49 gram. Okay, so now I'll show you some basic difference between normality and molarity. You just see here the molecular weight of potassium dichromate equal to 294 gram per mole. But the equivalent weight of potassium dichromate is 49 gram. 49 gram equivalent. So this is for molarity. If you want to make 1 molar potassium dichromate, what will be the method? You will take 294 gram solute plus 1 liter solute. 1 liter solution. Is it okay? But in normality, if you want to make 1 normal potassium dichromate solution, what will be the thing? Can anyone answer?
Miss, we will take 49 gram.
Yes, right. Here, it will 49 gram solute of this solute will be only 49 for 1 normal in 1 liter solution. So what is the difference? You can see here why actually normality is better. Why it is not appropriate. Nowadays in our laboratory we are calculating normality. Why? Actually, in case of molarity, you are taking all the solute, not specific the reactant actually. But in this case, you can see there for chromium. Here only the change is occurring in chromium. Chromium is showing the change is participating in reaction. So here normality is very specific. The error is much less for the unit normality. But in this case, you are taking all the spaces. But in this case, you are taking the specific ion only for chromium. You are taking the small part for calculating. So if you calculate in large part, then the percentage of error will be, the probability will be high. But in case of normality, it will be less than molarity. So nowadays, that's why the pharmaceuticals, the research in research lab or any other laboratory, we just prefer normality because we are taking the specific reagent, specific ion. We are calculating the specific species only for the calculation. That's why normality is very popular and advanced updated version of units for expressing concentration. So do you understand these things clearly? Is there any confusion on this topic today? I'm giving too much importance on this topic because it's really basic thing. But all of you know these things, but don't have any clear idea. So still, do you have any problem? Please, you can share. You can ask me. We have 3 minutes left. You can ask me right now anything. So today 32 participants I can see. You have total 37 classmates.
38, madam.
38. Okay. Okay. On this topic is end for today, but on the next class I have uploaded this slide. I thought that I will start this slide today, but this topic today, but I cannot manage. So I'm not going to start this one. Okay. I will start this topic on the next class, but you just please keep lecture khata with you and pen with you because my topic, my syllabus is related to mathematical problems, so you have to write down some notes for better understanding. Otherwise you will be just puzzled during your exam. Inshallah everything will be normal. Then that time you have to face difficulties. So that's why I'm telling you, please keep one lecture khata with you. Just try to concentrate like a student, like a class. Okay. So is there any problem, student? You can share.
Oh, miss.
Saima, can you hear me? Saima, can you hear me? Lamia, can you hear me? Lamia,
Yes, ma'am.
are you Lamia?
Yes, ma'am.
So do you understand everything for today's class?
Yes, ma'am. As far as I got, I was late.
Oh, I think you are sleeping. Is it?
Yes, miss, I missed the alarm.
Okay. So, what at which time you have joined? You should say that I have missed the class. Please explain the topic again.
Miss, it won't be a problem. I'll see the recordings.
Okay. Thank you.
Thank you, ma'am.
Okay, that's all for today. Have a good day. Stay safe. Allah Hafiz.
Thank you, madam.
Okay. Allah Hafiz.
Assalamu alaikum.
Walaikum assalam.